The story of black holes, from skepticism to wonder. Imagine a place in the universe where time slows to a crawl, where gravity bends the very fabric of space, and where light itself cannot escape. Such places exist. They are called black holes. But the journey to understanding these cosmic enigmas has been anything but straightforward. For decades, the very idea of a black hole seemed absurd. Even Albert Einstein, whose theories predicted their existence, refused to believe they could form naturally. He thought that as stars collapsed under their own gravity, their angular momentum, the way they spin, would stabilize them, preventing a total collapse. In this belief, Einstein was wrong. Despite skepticism, a few courageous scientists continued to study black holes. Among them was Roger Penrose, who in the 1960s made a groundbreaking discovery. Once a certain boundary, the event horizon, forms, the collapse of a star becomes unstoppable. The result is a singularity, a point of infinite density, where the known laws of physics cease to apply. This singularity is hidden behind the event horizon, a boundary beyond which nothing, not even light, can return. Penrose's insights were like opening the first chapter of an epic novel, and Stephen Hawking soon added another. Hawking showed that the Big Bang, the universe's fiery beginning, shared something profound with black holes, singularities. He also predicted that black holes aren't entirely black. They emit faint thermal radiation, now called Hawking radiation, a discovery that would change our understanding of black holes forever. The making of a black hole. To understand how black holes form, let's turn our gaze to the stars. A star's life is a delicate balance between the outward push of nuclear fusion in its core and the inward pull of gravity. But this balance cannot last forever. When a star runs out of nuclear fuel, gravity wins. If the star is massive enough, more than 20 times the mass of our Sun, it collapses into itself with unimaginable force. The outer layers explode outward in a supernova, while the core continues to shrink. For stars whose remnants exceed about 3 times the Sun's mass, not even the quantum forces that hold atoms together can stop the collapse. A black hole is born. And yet, the universe holds mysteries far greater. Some black holes, called supermassive black holes, have masses millions or even billions of times that of the Sun. These giants sit at the centers of galaxies, including our own Milky Way. How did they grow so large? Were they born from the deaths of the first stars, or did they form directly from colossal clouds of gas? These questions still puzzle astronomers, even as they uncover clues from the farthest reaches of the cosmos. A cosmic slow dance. As massive as they are, black holes don't sit idly in space. They grow by devouring gas, dust, and even stars that stray too close. Sometimes, two black holes meet and merge in a cataclysmic event, releasing ripples in spacetime known as gravitational waves. These waves, detected by observatories like LIGO and Virgo, are like whispers from the universe, telling stories of collisions that happened billions of years ago. But for an outside observer, the final moments of a star falling into a black hole are eerily serene. Due to an effect called gravitational time dilation, the collapsing star appears to slow down as it approaches the event horizon. Its light stretches into longer, redder wavelengths until it fades from view. To us, the star seems frozen in time, hovering just above the event horizon. The life and death of a black hole. Black holes, however, don't live forever. Hawking's theory revealed that they slowly evaporate by emitting radiation. The process is incredibly slow. A black hole with the mass of our Sun would take 1 followed by 64 zeros years to vanish, far longer than the age of the universe. Smaller black holes, on the other hand, evaporate faster, releasing bursts of energy as they fade. Some scientists speculate that primordial black holes, formed in the universe's earliest moments, might still exist, But these tiny relics of the Big Bang would have long since evaporated, leaving behind faint traces of their existence. NASA's Fermi Gamma Ray Space Telescope continues to search for these traces, hoping to catch the final, brilliant flashes of evaporating black holes. The edge of the unknown. Despite the extraordinary progress, black holes remain one of the greatest mysteries of modern science. What lies beyond the event horizon? Could black holes be portals to other parts of the universe or even other dimensions? And how do they reconcile with the quantum world, where particles can exist in multiple states and time behaves unpredictably? The story of black holes is far from over. With each new discovery, we edge closer to understanding these cosmic wonders, not as anomalies, but as integral parts of the universe's grand design. They remind us of the power of curiosity, the courage to question, and the infinite possibilities waiting to be discovered. As we gaze into the night sky, we are not merely looking at stars and galaxies. We are peering into the abyss, into the very heart of creation itself.